This is the Amp Hour Podcast, released March 28th, 2021. Episode 536, NFT Schematics.
Welcome to the Amp Hour. I'm Dave Jones from the EEV blog.
And I'm Chris Gamble of Contextual Electronics.
We're going to be rich, dude. We're going to be rich.
Are we? Yeah. Okay.
We're going to, yep. We're going to sell our schematics. I'm going to sell my firstborn video. I'm going to, yep.
Mm-hmm.
Yep.
And how are you going to do this, Dave?
I'm going to do it with non-fungible tokens. NFTs.
I do like the word fungible, but everything else about this,
great.
I hate. Everything else about this, I really hate.
You brought it up, dude. You put it on the list.
I did.
You're guilty. It got 0 votes, and we're starting off with it.
This all started as like a this angry screed I had like written out, and then I was like, yeah, I'll just post about it because I thought it would be funny to talk about on here. But yeah,
well,
the idea.
Where did you post it, on Twitter or?
No, on this Reddit post. I like had this like whole long thing about this.
Oh, okay, because you didn't
about
post
how silly
anything.
I think they are. Yeah.
So you wrote it all,
just,
and then you deleted
I just backspaced it. Yep, exactly.
It's quite a few people commenting on here. It's,
yeah. So, why don't you explain what these are, since you're in the whole crypto world, and I think it's ridiculous. So.
Well, it's good if you want to get into the intricacies of it, but
no, I don't.
It's hard. No. But basically, a non-fungible token is using blockchain. It doesn't have to be any particular type of crypto, although some are more suited to it, to basically verify that you're the owner of something. And that was one of it's not a new concept. That was one of the original issues for one of the things that blockchain could do is that it's a permanent ledger. Right. So it records. Everyone knows that you're the owner of that Bitcoin.
Yep.
But it doesn't have to be actual Bitcoins. It can be products. It can be, in this case, it can be digital artworks or something like that.
Mm-hmm.
So, yeah, it's just a way to verify that you own a digital asset. Well, you own an asset. It doesn't even have to be digital. It can be a physical asset. It can be like a Rembrandt painting or something, right? A physical.
It could be like a deed to a house, right?
It can be a deed to a house. It can be all sorts of things.
A piece of paper that says you own the thing, right?
Yeah, it says you own the thing. And a non-fungible token is basically that. It's using the blockchain to verify ownership, but it's doing it for where all the hype is at the moment is digital assets. So you can sell tweets. You can be the owner of Elon Musk's first tweet.
This is where I start to fall apart at the seams. I'm
this is where
asset is being used very loosely here.
I know.
Asset being thing with value, and everything that I've seen is very without value.
Oh yeah. See, that's the thing, because it's a digital thing. Like it could be a PDF or a tweet, like everyone else, or a picture, right? Artists are selling their digital their digital JPEGs as,
and this is where it all started with this. What's the stupid guy's name?
It's been going on for a long time.
Binky? No. What's the guy's name? He's got a stupid name. It is.
Is an artist?
Beeple is the guy that sold it. This is why it's in the news, because he sold a digital painting for like $66 million.
Yeah, I know. This is this is insane, right? Whereas a digital painting, whereas you can own that exact same JPEG, it's identical in every way. You can own it for free, but somebody paid $67 million to be the verified owner of the original, in quote marks. Right, even though it's a digital thing that you can copy with 100% perfection, like it's just it's insane. So it's relying upon the fact that down the road somebody else will be even dumber than you are to pay more than you paid for it.
Yeah, it's right. And so this is my next argument against it. It is the nouveau Beanie Baby.
Right. See, I was not into the whole Beanie Baby thing. I didn't. That wasn't here.
You think I was? You think I was?
Right. Well, I don't know. You'd might know. It was an American thing, I think. You'd know more about it than
American
me.
thing. Yep. Yeah. No, I was right in there. Yep.
Yeah, it's just and pet rocks, and well, not quite, because it's like there are uses for this. It's not absolutely useless, right? There are real legit applications for non-fungible tokens.
There was uses for tulips in the Netherlands in the 70s.
No, come on. You said it yourself, right? Deeds to houses and things like that, right? To verify ownership.
You could have planted. The famous example is the tulips in the Netherlands, right? They had this like crazy valuation that kept going up and up and up, and you could have planted them. You would have been wasting a lot of money that you spent on a tulip bulb. But
yeah. And
anyways,
then it just
I thought it was funny because
overnight.
Thinking about this like for a schematic or for an electronics design, it's a thing that actually, I mean, maybe the design itself doesn't have any hard value until you actually make the thing out of it. But you could say that the IP and the data around it has
you could say like, what's the most famous schematic? Like a lot of people say it's the Apple One schematic, right? So in theory, if Apple came out and sold that as a non-fungible token, right, to verify that you own the original drawing.
Probably wasn't a PDF though.
That's right. No. Well, no. It's because that exists in paper form. Well, no, it was done Oh no, that was drafted, wasn't it? It was drafted. Yeah. So
like that photo you posted on Twitter this week of all those people on drafting tables.
Oh yes, yeah. Back when that was the day. Yeah. Well, that was the thing. Did you ever study technical drawing? Because I
never did
this out. So it was part of my early engineering
I never had
study
to.
Was right.
I think I was just on the edge of it though.
That doesn't surprise me.
I think some of the mechanical engineers that I'm
sure they
went to school with, they still had they had a very traditional class. They were still doing like manual machining and stuff like that. So they weren't doing like CNC, but it was all about like measurements and drawings and stuff like that. And I think they made a hammer at the end of it. So
I can remember doing the class, and you had to learn technical drawing. You had to learn the 3D projections and the orthogonal projections and things like that. And I still actually remember all that stuff. And
does it have any relevance for you today?
Well, people have commented on my whiteboards how that looks kind of like your angles are correct for doing your when I try and draw a 3-dimensional object on the 2-dimensional whiteboard, people go, I've had comments that, hey, that looks pretty good, David. The lines are a bit wonky, but the angles sort of make it look good, and that comes from I'm not an artist, but
okay. So take a drafting class, and then many years later, someone might be like, "Hey, Chris, nice whiteboard."
Yeah.
Okay. All
Literally 30 years later, I still remember the basics of that.
Worth it. I mean, does it have other benefits though? I mean, like, does it have other benefits that you see or no?
Not really, apart from getting concepts across as sketches and stuff. Like, if I was doing anything serious, you do it in CAD now, and CAD takes care of it all for you, Yeah. So it does the 3D modeling, you do your 2-dimensional drawing, and then it takes care of the 3-dimensional stuff and things like that. Yeah. But, it's learning how to dimension and do other things,
That's true. Yeah, tolerances and things like that.
We've mentioned schematics, like package drawings. They screw up the dimensions, and that they don't know how to dimension their package, pin out their package dimensions properly in data sheets and stuff like that. Had a few rants about that people have on Twitter over the years. And
I have. I mean, I feel like it's actually always drawn from the mechanical engineer's perspective, and we want it from the CAD perspective.
Yeah, we want it from the we want it from the usability.
We want pitch, and we want to know pad width, and we don't want to know about all these other crazy ass. And it's like I'm never going to verify a SOIC.
Yeah, and you don't want it dimensioned all from one point either, because then you've got to add and subtract things. And
I want it from the centroid of the entire part too.
Right.
All these things that are like, I'm sure we've talked about that on here before. But man, that one stinks.
Yeah. Anyway, I think it's still a useful skill. But leave it in comments down below, please. Do you, if you're a recent graduate, I'm sure I'd be surprised if anyone's doing it. Surprised if there's a class.
It's interesting too. Sometimes like curricula kind of lags behind. Like I was actually my buddy, one of my buddies who's a classmate. He was asking me about like what we used in school, and like we were so this was like 2000 2003. And so we were learning on like Quartus 2, which I think came out mid to late 90s. You know, like it was, but because the educational materials lagged behind, we were still doing like gate level design by drawing schematics instead of doing, we probably should have been doing Verilog. And, you know, if anything, I learned VHDL on the job, I think, from my coworkers. Yeah, later when I started interning. So
even into the late 80s, even in late 80s, early 90s, like we were still learning 6502 assembly language, and we had these antiquated in-house designed development boards, you know, and it was like, oh God, no, come on. It's like, you know, we're still learning ancient microprocessors when, you know, microcontrollers are the thing now. It's like,
right,
you know.
right. Yeah, I mean, some of it, I get it. Like, it's tough to develop curriculum and stuff like that, and they don't want to update it all the time. But also, yeah, I want the newest things. Like, you know, like, and every time I bring this up to professors, and I'm sure I've brought up on the show before, they're like, well, we can't keep up with all that stuff. And it's like, well, then what the hell am I paying you for?
Right. And I can remember, right? Well, this technically, well, it was the late 80s, so we didn't have digital scopes like we did these days, you know, the little compact, you know, super powerful beast, but they did exist. And it was like, but we still had analog scopes, right? We learned all on analog scopes, right? Labs were filled with analog scopes. And it was like, the engineering department had one digital scope, you know, and it came like, and it was, you know,
and you're not allowed to touch that.
I can remember when it came out, and the lecturer had no idea how to use it. I had to show him how to use this digital scope. It's like, you know, he had no idea because like it just got wheeled out, like, you know, once in a blue moon.
It's like the showpiece.
It was like the Holy Grail, and it was, you know, all the priests in white suits would, you know, stand around it and chant, and you know, oh boy, yeah, digital. But yeah, it's just when they were as common as mud, right? Well, they, you know, but not as powerful as they were now.
Yeah, but they were expensive, and
but they were expensive, and they were, you know,
and there's no curriculum for it. I mean, honestly, I get it from the curriculum piece, but I feel like, you know, like some of the best things, I really like when companies come in and start to like develop training and stuff like that too. Like that's another big investment, of course. But I know like TI does that. They have some educational training and things like that to try and like hook you young and get you using their parts and things like that. So that seems kind of symbiotic in that way, but it requires a company of significant size in order to do that sort of thing. And then also depending where you're at a program that they do that. But I just kind of feel, I guess the thing I wish most would be like just that the curricula would actually go out and point you at the things that you really need. There was actually just a tweet from one of the Google engineers was asking about like, why do students not ask for things that would make research faster or better, right? They're like less willing to spend money. And one thing that comes up for me is, it was two things that came up for me. One is kind of just that general cheapskate mindset of being a student in the first place. But then the other is just not knowing about it. Like you don't know until you know. Like I didn't know why one scope is better than another scope because I was using it at the very beginning of my journey. And so it was just like, I don't know what all these other knobs do. I don't get it yet. And so I couldn't discern quality in the first place. And that kind of is what it comes down to for it, unless you're like in the thick of it and like really struggling and being like, oh, how do I do this one thing? And then the old engineer comes over and he, you know, turns the knob on the scope. He's like, oh, there it is. That's how you do it. you don't know you need that thing until you struggle with it and Google around or ask the experienced person or whatever. It's just really tough to get your arms around that knowledge at first.
Well, and it was harder back before the internet because, well, you didn't have the online community. You weren't exposed to an infinite number of things like you are now. It's like...
Yeah, right. Yeah, now you could Google for it, yeah.
Now you can go into your university lecture and you can go, well, why aren't we learning about, you know, ESP32s and RISC-V and, you know, all this sort of stuff? And it's like, well, you just didn't know about this stuff pre-internet, you know, it just...
RISC-V.
RISC-V, sorry, RISC-V. Yeah, RISC-V.
Okay. I feel like that's going to be a thing where I'm going to keep correcting until the end of the time. It's cool though.
I should know that because like nobody ever says the the Fluke 87V. It's right. It's the Fluke 87.5, right?
That's right,
it's like so yeah, I'll get that right eventually. But cool. you can probably see this not happen or happening a lot less with software that's automatically updated, like CAD software, for example, Altium in schools or something. You're not going to be likely using a 5 or 10 year old
not
copy of Altium. No, they're not locking it down to the old one. You're going to get the automatic. Yeah, exactly. You're going to keep getting the latest updates. Whereas people in industry, this is where the one place where students might actually be ahead of the industry, because the industry might be still stuck on Protel 99 SE. Right. And trust me, someone who's worked at Altium, like half the industry was stuck on, especially in China, was stuck on 99 SE for 10 years. Like nobody updated because it worked, and it like, don't mess with my CAD tools, they just work. So you're stuck with the old version. Whereas you came out of your engineering course and the latest version. And you've got to go back to this old school one at some company because they don't want to upgrade because reasons, they just don't want things to screw up.
Well, I mean, it's tough. Tool chains are just like, they get ingrained in companies and cultures and internal training and just, lots of things. I mean, think about all the hooks from software.
Oh, yeah. We'd hear that all the time from the Altium sales guys. We can't sell them the latest version. They're just so stuck on 99 SE and they won't budge, the bastards. Even if we give it to them for free, they won't take it. It's like...
that sounds right.
It took a long time. So
I believe it. Yeah, you have to wait until the machines give out and they can't install it anymore.
Behind the times. Anyway, what else we got?
So I've been working with a mechanical engineer who I really like, and he has been printing in resin, and I am just amazed at the. Did you ever get a resin printer or no?
I do have yes, I do have one. I have what are they called? The name escapes me now. The laser,
SLS?
SLS.
Or SLA.
SLA printer, yes.
Yeah.
The selective...
SLS is the powder, SLA is the goop.
Yeah. And then you've got to clean them with isopropyl. I got it back when you couldn't get isopropyl because of the COVID thing.
Oh,
this thing turned up and I didn't have enough isopropyl to spare to, Yeah. Yep. So technically I do have one, but...
I mean, I'm jealous, I think, just of the iteration kind of stuff, that still doesn't exist for electronics in any appreciable way, but just like the quality of the prints that he can iterate on are just unbelievable. Like just being able to do that over and over again. He'll have 3 sets of prints in 2 days.
Oh yeah.
Right. And like be able to iterate like that. And I just I sometimes I can't get parts in 3 days or at all, really.
I still remember being blown away. You can see the video. We might have to link it in, of where I opened the package of my first custom 121 GW multimeter, right? I didn't know what they were sending me. And they sent me this clear resin printed prototype thing. And it was like, wow, and the case, it was 2 halves of the case and it had the knob and it had it was just absolutely incredible. Just to get a look and feel for the multimeter was absolutely amazing.
Yeah, and there's something about that. I mean, like you could look at it 3D prints all day, but man, holding it in your hands.
Yeah, holding it in your hand. Yeah, it's so very different.
Can't get over that.
Yeah. I was just blown away. So, yeah.
It's too bad. I mean, and boards are cheap and fast, and I think the real thing is too that people are going to say, oh, you've been able to get SLA prints forever, next day, whatever, fast. But like having that in-house is different. I think being able to just run it, and like not having the fewer like friction layers you have, the better off you're gonna be in terms of iteration cycles. And it's like, you and I have talked about picking places on here, of course, and board milling machines and just all these different things. And I guess I'm just real jealous, I just want a 6-layer board printer at home, that like is like reliable and always works. Yeah.
Yeah.
It just, it doesn't
Dream
go,
on. What this segues into? DigiKey are now printing. This is the best thing since sliced bread. They're now printing the DigiKey part number and the values and stuff, the details on the back of the cut tape.
Yep. It's cool.
This is
I got to see this early. Ben from DigiKey showed me this early, and or pulled me in to show it early with some of the other engineers there, and it's super cool. The first thing I thought of, what's the first thing you think about doing with this?
I've often done this a lot. I would get out my permanent marker and I'd write on the back of the cut tape. I physically had to do this. Now it's like, but I do. So what's your question? What
I think my thing is, the thing that I said is like, oh, I get so upset whenever I go to buy like a parts kit, like different values.
Yep.
And, they're just so expensive for what they are because someone somewhere is doing cut tape.
Somebody has to manually cut them and label them and so on. And sure. I've had those ones. I've bought those kits, those resistor kits, and they actually mark the value on the back of the tape. So,
exactly. But that's what you were paying for. And then you were paying above and beyond. But now you can make a completely custom of your own. All you need is just a little box. You go and print you basically just order a bunch of values and then you just throw them in a box now, right? In one fell swoop, they have obviated the get a resistor kit, get a whatever kit.
Yes, you can buy your own resistor kit and it's done for you. Yeah.
Yeah. I mean, you've always been able to do this, and usually they're like vendor kits. But like if you go on to DigiKey or Mauser or whatever, and like you go to actually buy one of the kits from like an AVX or a Kyocera or something, whatever kits you want to get, they're pricey. Like they are.
Oh yeah.
Because really they're promotional things usually.
No, you have to get them from the One Hung Low factory in China off AliExpress if you want cheap.
Right. If you want, but I want cheap and quality, and
you want known manufacturer. You want to know it's that capacitor. You don't want to know it's just some random,
Right. Especially if I'm like going like getting like in 0.1 picofarad increments or something like that in an 0201 is like, okay, well, I mean, I could get those from wherever, but I think by the time they're offcuts from some lot, it's like, I guess I'm not going to go and measure 0.1 picofarads to verify every part. I want to just know that I have the actual part number. So anyways, that's what I thought of immediately. So make your own kits at home. That's kind of nice. I think Ben said eventually they're going to actually mark, maybe they already do on the site when they are, when the labeling is available. Cause I think that would be really necessary so that you're not just like ordering random parts and being like, oh, none of these are labeled.
That's a long standing thing that I've been meaning to do for years. I've been meaning to actually collate. We've got already actually got a spreadsheet of all these types of stuff. I've even got a sort of a kit. Anyway, I was thinking about selling a folder with a starter pack with all the devices, like jelly bean parts. It'd be a jelly bean starter kit. It wouldn't include passives.
Because it goes with your sleeves, the sleeves you sell, right? I mean, like that's something you already do.
So I was going to put them in the micro sleeves, and I still sell the micro sleeve. I've still got warehouse full of
micro sleeve.
It's great. I should send you some.
I know it's a great product idea. I like it. It's just the name, Dave. I'm just like, what? I get.
What's wrong with micro sleeve?
I know. It's your brand. It's fine. It's just
okay. Oh boy.
You want a DMM? Micro DMM. You want a current measurement? Microcurrent. You want a supply? Micro supply.
And don't forget the micro calc and the micro watch.
That's right, of course.
Yeah.
Right.
So, I used to sell my micro watch, that was a kit. Used to be able to buy. People still ask for it. I've got the webpage somewhere. I still,
I'm sure you do,
every couple of months I get an email saying, hey, can I buy one of your micro watches? It's like, no, dude, I discontinued that like 10 years ago. Stupid ass me still has the webpage up, Yep. And even web pages, like these old web pages, even if you put the information there, this is all the information I have. Please don't email. Don't ask, I've got it on the webpage that says all this. They email you anyway saying, hey, do you have this? And boy. Yep. Anyway, just the other day, I had to send somebody an old PIC binary file for one of my video overlay projects that I've done a video on. It's like, he said, have you got the binary for that? I just need the binary. It's like, okay, I dug it out of the archives and sent it to him. Yep. Anyway. Boy. Guess what's back?
What's back, Dave?
Well, this is today's video that I'm working on. The thermoelectric generators are back. Thermoelectric generators and the impracticality of them. It's like, there's this paper that, I'll send you the link to the paper.
I mean, there's the RTGs, right? Which is like what's on the Mars rover and Mark Watney used in the Martian.
To keep yourself warm. And
most things are not operating from a radioactive level. So power levels are pretty important.
There you go. I'll send you the link to the paper.
Is it a delta T that determines the power output? Like what is the actual like linear element there?
Yes, the maximum power point. Well, if you look at the maximum power point curves, I can actually send you the direct image to copy image address. There you go. I'll just send this to you. makes for great radio.
Yeah. We're just getting on the same page here, folks. Literally the same page. Yep.
There you go. You can see the maximum power point curves, and they're just like a bell shape. Oh, they're like a a typical curve, right? And yes, you can get 1 volt out of these things. And if you read the paper, they made like the world's biggest, the world's highest output voltage thermoelectric generator. This is actually really quite cool. It actually goes on your skin. It's actually flexible, and it's actually a self-healing polymer. So when it bends and flexes on your skin, right, it doesn't actually break. It doesn't, break down. Like it doesn't actually destroy itself, right? Just through bending and stretching and stuff. So it's kind of like a really cool innovation. And but they've like their abstract says the world's best highest output voltage thermoelectric generator, and then you you don't even have to go past the abstract to read. Oh, by the way, that's at no load. Right, 1 volt at no load, and at a 93-degree temperature differential. Right?
Oh my gosh!
Yeah, exactly.
So it's like you got ice on one end, and you got it, and you got a fever on the other.
You're basically dead. So this will only work if you're standing on Mars, kind of thing. And then you'll only get 10 microwatts out of it. Right.
Oh, wow.
And of course, 10
microwatts.
Microwatts
on the y-axis.
Microwatts, right? So, you haven't heard the best of it yet. So, even under ideal conditions, right, 93-degree temperature differential, it'll give out 18 microwatts, right, is the absolute maximum, but it'll only give you half a volt because that's where the maximum power point is on the curve. So you have to know, it's the top of the curve is your maximum power point. So I only give half a volt. Okay. So what do you get actually in a realistic scenario where it's on your skin at, 37, 35 degrees or whatever, and then ambient room temperature? Well, you get 100 nanowatts. It's like, it's dropped from this magnificent 18 microwatts, which can barely power a Casio watch.
Maybe this is why people are asking for the micro watch. They're like really low power, right, Dave?
Yep. and you can't, and they're saying, oh, it'll power the Internet of Things and wearables and everything. No, the only wearable you can power, you can't, I'm calling it now, you can't power any wearable with this. In a practical scenario.
I mean, maybe like a custom ASIC, like something.
No, it's not even going to do it. You'd have to be operating at 100 nanowatts.
I know.
What are you going to do in 100 nanowatts?
Well, if you really accumulate the power over time, you build it up in a battery.
But you got to build it up. No, that's just, you got to energy harvest. So you'd spend more.
I mean, that's how most of those things work though too. Like when you see like the RF harvesting, things like that, they're storing a charge and then they're just doing a single operation.
Yeah, they are, but when your DC to DC converter and your energy harvester takes more power than your actual device does, you're kind of screwed, right?
Oh, yeah, I think if you're starting from this point, you're kind of screwed. I mean, this is research, right? I mean, this isn't
it's research, but the thing is, like, and one of my favorite YouTube channels, they actually read this paper and they got all excited about it and everything.
Oh, is this the two minute papers?
No, this is okay. Anton Petrov.
Oh, okay. Yep, Anton's good too. Yep.
Hot to Math channel. Anyway, my video is kind of like a response to him, and he got all excited about it. Fair enough, because if you read the abstract, it sounds fantastic, but when you actually go in and look at the actual data and do the back of the envelope calculations, you realize you can't power anything with this thing. And anyway, it's really cool research, right?
But we would love to see if people do. I mean, like, hell, go for it, man.
Okay, if you can develop something that does a useful thing on 100 nanowatts, go for it.
Exactly.
Sure. Right? And
that's
then you
got a
can put
paper
it on
in
your
there, I'm
skin
sure, too.
Yep. And then it doesn't work on a warm day, and so it only works if you're room temperature or under, or if you're in a cold climate.
This is a Chicago rated device from January to early March.
Right. That'll be on the spec sheet, will it?
Yeah.
Chicago rated. Right.
Chicago or above, right?
Right. Vancouver rated.
Yeah, right.
Yeah. Oh, boy. Yeah. Anyway, I just so I had to do a video on it because people just read the banner spec and they make all sorts of claims, and you can't blame the researchers for getting all excited, right?
I mean, so in the realm of getting excited about specs and and MPPT, I'm actually excited about this new part I just sent you here, the BQ25798. I'm using the BQ25895 right now on the ABC board. And so, it could take solar input, could do this, it's doing all this other, it's fast charge and a lot of that stuff. This one's kind of interesting because it's basically, it can do higher charge output and higher voltage input. And so this is basically now, like before I could only do a 6-volt cell because, I saw the spec of like, 14-volt input on a BQ25895, right? And I was like, I could do a 12-volt cell. It's like, well, if you get it biased wrong, you could have more than 14 volts in the input, and that would be bad times for all. So
it goes down to 3 volts minimum. What's the startup? Does it still start up at 3? Because that's a thing with that's the trap. Banner specs with these energy harvesting things. You got to
totally
right. Yeah. Banner specs will say, it works down to 20. Like some of them work down to like 20 millivolts, 20 or 30 millivolts.
Yeah. Like energy harvesting.
Yeah,
chips
energy harvesting chips, right? Insanely low voltages. But the trap for young players is that they don't start up at that voltage. You've got to have like 200, 300 millivolts.
It's like inertia,
start up.
right?
yeah. Once it starts up, then it's all running. It can go. It can drop back to 30 millivolts, but it can't. It can't start up at that.
Right.
So
you need that charge you stored in the super cap next door.
Yep.
to get it to wake back up and do its thing. Yeah.
Yeah. Don't get all excited, but cool. This is little I2C interface jobby. And
I like this family of chips too. I mean, I first found these because I was, like I said, this is what I was doing for the ABC board, but I like this because, like having to switch in without having to think about the battery, and it's just kind of doing power path stuff. That's cool. But this one actually now can do higher loads. So if you're actually trying to do like multiple stacks of batteries, if you think about like having like a practical battery stack, like when you're like out in the real world.
Yeah.
Having a single cell lithium ion is possible, of course, but this kind of thing is like, no, now you can actually start to get some more serious power in your battery pack by stacking cells and things like that. So
and it's actually got a tap point. Doesn't? No, it doesn't. You just put them in series, so it's not. It doesn't tap off each cell.
Yeah, it doesn't do like individual monitoring, anything like that. So I think
it's fully programmable too, is it? And is the output voltage fully programmable too? It says 2.5 volts to 19 volts. Is that like a fully programmable output power supply?
No, you'd have to follow this on with a regulator as well.
Okay.
So you'd have to put like a downstream buck if you're
handling. Okay, right. So this doesn't have a built-in voltage regulator.
That's right. Yeah.
Okay. Right.
Yeah. So this is mostly a charge chip, and then you'd put this out front of this is basically your incoming, your power handling, that kind of stuff.
Yep. Gotcha.
But because you can run off a panel, you get a pretty wide range of panels. That's where it gets pretty cool.
And so charge current up to 5 amps too. That's pretty grunty.
Oh yeah. I mean, because all these things are like all these parts are doing.
So do 100 watts.
Yeah, I mean it's USB-C spec'd, right? I mean that's really usually when you see the 5 amp thing, that's usually what they're talking about, is that you can switch in you can do PV panels, but then you can also switch in like a USB-C and handle that kind of current if you have the PD chip in front of it. Yep. So yeah, it's
cool.
Neat. Yeah,
I like it. Yep. Is it a newbie?
It's brand new. So I just got a eval board. They sent me one.
Right.
And it's eval boards are just nuts these days. Just like the number of.
Hang on. I'm looking down the bottom of the page at the technical documentation. The first document is June 2014, and the title, I kid you not, the title is "Summertime and the Living is Easy."
Really? I didn't see that.
What? Yes, I'm clicking on the link now. Summertime. Yeah, it's a blog. It's a TI blog. Summertime and the Living is Easy. Song lyrics, George Gershwin.
I think this is just like a referral talking about solar, I'm guessing.
It's just a blog article. Yeah. Okay, so, all right. Oh, God.
That's what they link to, I guess.
Come on.
Summertime.
That's in their technical documentation.
Yeah.
Come on. Really?
Yeah.
Oh.
I was actually opening.
Anyway.
I have a junk box, and I have just some like raw solar panels in there. I'm just like, where did I get these?
Right. Yeah.
And so I'm gonna try and like just plug it into this thing and see how it goes. We'll see. I mean, I'm gonna measure the output first.
Well, I found my whole box of flexible solar panels the other day. Those printed on polymer sheet ones. I've got a box full of them. So
yeah. What's the output for those?
Oh, it's not much. They're like 2%. If you think 20% efficiency of regular solar panels ain't that great, these are about 2%. Yeah, they're not. they're not great. But the thing is, they're flexible. You can roll them up. You can, you know, they're they're really quite cool. But yeah, the efficiency's not. I don't even know what the state of the art is. I don't even know if it's hit like 5% yet or something like that.
Yeah, but if you're camping, like it's better than, you know, not having an LED lamp for at night.
Yeah. Well, I've got one of those fold-in, you know, camp solar panels. You know, big 100-watt job. It sort of like folds out into 4 big panels, and it's got little stands on it that, you know, so pretty good. Anyway, speaking of design choices, it's kind of I'm stretching the segue a bit, but I wanted to talk. We discussed this, that maybe we'd talk about when to make design decisions. We're jumping to really complex design now. When to make the decision whether or not to use an off-the-shelf operating system and you know drivers, you know, like to drive USB stuff and things like that, and to do MPEG encoding and, you know, codecs and, you know.
Yeah, I think the conversation was about like when to write stuff from scratch, like so.
When to write stuff from scratch. And can we say where this comes from? Yeah, I mean, we probably can.
I think we shouldn't make any promises in case it falls through, but like, there's.
No. It's anyway, there might be something coming up with this on the Amp Hour. But anyway, Black Magic Design. You know, I've been playing with their ATEM switcher, and you've been lusting over one of these.
I don't have any place to put it, so anyway, that helps a lot.
Right. Oh, okay. Right. So, I found out that they, it's probably no secret, that they actually write all their own stuff from scratch. They don't, like, you know, I've done a teardown of this thing, and it uses like a $500 Zinc processor chip with 5 cores on it. You think, oh yeah, they're running Linux, and, you know, because why would you do it all from scratch?
Wait. Actually, I didn't get this from our conversation. So you're saying they wrote the operating system from scratch too?
Oh yeah. They wrote the operating system from scratch, apparently. Right? They wrote they've got their own operating system. They wrote their own MPEG codecs. They wrote their own USB drivers, everything.
Wait, their own distribution or their own, you're going to have to clarify later, but well,
this is what I've heard, is that everything is written from scratch.
I could see. So here's where I draw the line personally. Like, you're going to write your own drivers. That makes sense. You almost have to. You probably have to, unless you're working with a third party that already has pre-written drivers for something. That's fine. Encoders, I don't really know how to write an encoder. So I'm sure that that's probably something that's in the software realm. And I'm sure that like that makes sense to have, you know, some kind of IP there that you're not just like buying off the shelf from someone else, but an OS, like a full OS.
Because I think a lot of these you have to license. You know, a lot of these, like, you can't just like, you've got to actually license a lot of this stuff.
Well, and there's 2 levels too, right? There's like the software piece, but then if there's like hardware acceleration in the FPGA, you might buy an IP block, and right. So like that's something that Sammy was talking about a little bit last week on our show with Sammy from Finix, and then Brian from QuickLogic also talked about that. You know, like that's just a big piece of being in the FPGA space of like, you can kind of buy your way towards pre-qualified IP, and it makes sense for some things, but then you are using the same, you know, you have the same spec someone else could just get.
We did this. We were working on a hugely, like, the 5-kilometer long underwater streamer, and, you know, it's got thousands of data acquisition, you know, hydrophone sensors and everything, and it's all fiber optic connected, and we had to send stuff from the very end 5 kilometers down all the way back to the data recorder at the front end. So we have to packetize everything, you know, and it's got to be real time as well. So I can't remember the protocol. What was it? T5 or something? There's like a serial. There's, you know, serial comms protocols, and we thought, oh, should we
real fast?
Yeah, and it's all real time as well. So it does it, you know. So there's no there's deterministic latency,
delay
and,
state,
you know, all that sort of jazz. And we thought, oh, should we write this ourselves? And then we went, no, let's just let's just not dick around. We don't have the time or the resources. Let's just buy an off the shelf VHDL core that just plugs in and does it. And it turns out that kind of sort of worked. As it turns out, we contacted a company that claimed to have had one of these cores. That sounded like it did exactly what we want, right? And it was like $150,000 or $100,000 or something, but that's cheaper than actually developing it yourself from scratch, right? In man hours.
Yeah, I was gonna say you always couched against like how many engineer hours it would be otherwise, right? It's just...
Yeah, exactly. And we did the calculations, and everyone was saying, yeah, all our VHDL guys, no, let's just pay the money. Let's pay the 50 grand or whatever, and just get this core. And sure enough, like we, paid our money, and please, can we have our core, please? And they went, oh, yeah, we'll get working on that. And like they hadn't written it. They had just
a spec. Just a spec.
They had to write it. Wow. Yeah. Yep, just a spec. All they had was a spec, and they went, shit, somebody bought it. It's like in Ghostbusters. It's like the alarm goes off. Right. We got one. And they had to start working on bloody writing the thing. Unbelievable.
That's bad. Yeah. So I think the thing is, like, I think there is some benefit, like in a case like that where you're doing a super specialized project or product rather, and you already have a competitive advantage in that you've won the bid or you're an expert in the space, whatever. Like, yeah, buying someone else's IP is not a big deal because you don't need to differentiate based on that IP. In the case of like having the fastest video compression, like there's tons of people doing video compression. So I could imagine that there's reason to try and optimize that and try and do that for your spec hardware or whatever.
But at what point in your development cycle do you decide we're going to write all this from scratch? It's we're going to take this R&D hit now, but trust me, in 10 years, if you're the CEO, trust me, in 10 years time, this is going to pay off big time.
I would say for me, it would be Rev 2 or 3.
Right. Okay.
Right, because you still need to like prove that you can do everything else. I could see like getting super bogged down with the we should, we gotta soup to nuts, we gotta own everything here. It's like, okay, but like let's get something in the marketplace. And, like
right,
like duct tape and bubble gum, fine, whatever, but get a prototype out there. Get to Rev 1 without it.
Oh, so you're talking about like further revisions of the product, get a product out there that runs Linux and all drivers, and then secretly in the background you have a little skunkworks team working for a couple of years, and then magically out comes all your own custom thing.
Right, and then you have something to like benchmark against and improve against, and you have like and I think most importantly is like having something that customers are already using and telling you about. Now, granted, that doesn't always work because people sometimes want to hold stuff closer to the vest. That's fine. But like even like internal users or people who are under NDA, just like anything that gives you some semblance of like being able to test it in the real world. I think that's really important. And I think a lot of engineering organizations wait way too long on it. They're like, oh, no, it's coming. And then, 3 years later, you're like, oh, cool. Well, thanks for telling me about that 3 years ago. What would you do?
I mean, boy. Please, if there's anyone out there has done this, like, or your company's decided to do this, I'm going to write.
Well, will they tell us though? That's the real question.
Well, no, maybe not. It's but it's not hard to sort of go and extract the log in via the debug kernel or whatever, and try and extract it. You can see what stuff they're running. It's not hard to sort of get in there and they're not running Linux. They must be doing something secret squirrel.
You're saying it's not hard. Would you be able to do that? Because I wouldn't know how the hell to do that.
No, I could go in there and, I could look at what, because there's like a boot code, thing. There's usually like a UART output or something like that. And if it doesn't have all the requisite stuff that you'd normally see in a familiar OS.
Dave's putting on the hacker hoodie here, folks. That's what I'm hearing.
Right. It's pretty basic stuff. Hooking up a UART to a couple of pins, it's not rocket science, right?
That's the thing. I never reverse engineer anything. Like, I just don't. I mean, like, I know that it's like a skill and I love watching people do it, but man, I just don't.
Yeah, I don't do it. I just have a peek to, just for shits and giggles.
People like look at like firmware decompilation and stuff like that. I'm just like, wow, what am I looking at? It's just a pile of gobbledygook.
It's amazing. Yeah, I made hats off to people who reverse engineer stuff from scratch. It's just crazy.
I just the not doing Linux or not doing like some like off the shelf OS that I don't.
Yeah, understand. I know it doesn't.
But again, like, I think some of this is like, so some of it could just be like engineering culture internally, right? It's like, well, no, we have to do custom because we need to be super secretive, whatever. Okay, fine. But like, I feel like so many times it starts as, well, Marty started writing this thing on his own and then he kept going with it. And now we're deep in it and we just got to keep going. And then it's like, you just end up building the same thing over and over again.
Oh, Yeah, I can remember I worked at a company in the late 80s who did security stuff, right? And they would develop, like, it was all Z80 based, but then they decided they were working on this new high end, fancy pantsy product. And they were like developing their own, like, obscure graphical operating system or something. I'm going, like, what? Like, why the heck are you doing this? And they were like designing their own serial cards and stuff to plug into, like, I'm just going, no, there's all these industrial, just buy this industrial PC and you can get like 8-channel, 16-channel UART cards off the shelf that you can just plug in. Why are you designing all this? And they, I told them about it at the time. There were no Google links, so I actually bought in magazines. I physically bought it, Electronics Design magazine, the US-based one. I used to get that actually delivered here, and it was a big thing because you couldn't get it at the newsagent here. So I get, subscribe to that, and I'd bring that in and show them ads for these boards, and they went, "Oh, you can buy those, can you?" And I went, "Yeah." You've been able to do it for a long time. They went, "Oh," but they were too far down. Like they were too far in to change it all. So they just went with their custom.
Sunk cost fallacy, I believe it's called by the economists.
Oh, yes. Yeah.
Although most people usually skip the fallacy part. They're like, yeah, sunk cost, man. Yeah, sunk cost.
Sunk cost. No. Oh, but they were there. They sort of had like a working product almost ready to ship. It was like you wouldn't say.
I don't know. Yeah, I think it's a tough thing. Like in any engineering organization, when do you decide to turn that crank and switch to that new processor or whatever, right? Like people talking about like, oh, we could never switch our processor. And like some of them are right. They're like, we don't have the code. We don't even know how. We don't even have the source code to look at in order to do a functional equivalent. It's just like, oh, okay, well, yeah.
Well, Kane/UEI did that with the 121 multimeter. I actually had. They went through like three prototypes. I've got 3 prototypes that use an old PIC 24F. Chip, right? I had to choose. They originally thought they couldn't find one with LCD driver, but I found one for them. Look, here's the PIC 24F, and they went, "Yep, we're all familiar with the PIC and everything." And so we, the prototype was practically done. They were working on it. Then all of a sudden, I got an email saying, "Sorry, company's switching to ARM. We're switching to ARM. We're going to scrap the PIC. We're going to rewrite this from scratch." And like, I was like, I've been working on this for 9 months. It's like. And they, sure enough, they just turned it around. Like 3 weeks later, I had another prototype in my hands with an ST32F something or other in it, and sort of worky firmware.
Right, that's great.
It was amazing.
Might also speak to the complexity of the firmware on there too.
No, well, like they didn't have to write it from scratch. A lot of the C code they could port, of course, but it's like that's
non-trivial for sure. Yeah.
That is non-trivial. I was just stunned when they did that.
That's great. And I think and that kind of thing is a good move, right? Like making that shift over. It's like,
oh, of course, I'm sure it paid off for them. Yeah. Yep. No, they just went, oh, look, we can't do like a lot of the stuff that we want to do with like potentially updating firmware over Bluetooth and doing other, and SD card stuff and stuff we want and projects we want to do in the future, other products. Let's just move to ARM now and take the hit. And
and that is usually like an overhead type of thing too. If you think about if you're an organization, it's like, you can't. I mean, that's not money. Your client's not going to pay more for the feature of being on ARM now, right?
Oh no. You have to sink that cost. You have to eat it.
True development cost right there.
The old pivot. Some companies have not pivot and died.
Oh yeah. Oh.
U-beam.
Different reasons, Dave. Different reasons.
Yeah.
As of a couple days ago, you could go and you could put an entirely new OS on your device. Have you seen this news that came out?
No.
Yeah, they just released.
Tell me.
An alternate. So the creators of Unix, right, the forebear of Linux, and all of its variants. There was another OS that came out of Bell Labs called PlanNine from Bell Labs.
Sounds like PlanNine from Bell Labs sounds like a thriller, like a spy thriller.
PlanNine from Outer Space is actually what it's named after. Have you ever seen that movie?
Oh, okay. That's right. That's in the back of my mind where I got that from.
Right.
Okay.
I forget Wood is the guy who made it. It is listed consistently as the worst movie ever, but
right, really.
I used to do bad movie nights. My buddy's father used to collect like bad movies and like bad horror movies, and so we'd go over there and watch them.
Yeah.
I have seen some doozies, let me tell you. PlanNine is very bad as well.
Hang on, haven't you taken me to task for watching B-grade crap on Amazon? I do believe you have.
This is Z-grade, Dave. I mean, this is
right.
like specifically because it's bad. It's not because I'm bored and like I'm trying to find something that's sort of
so this is below Amazon Women from Mars.
Oh, this is
Well,
no, this is actually. I think this is the Amazon Women from Mars kind of thing. I mean, like, yeah, this is. Rats was one movie that I watched that was terrible. There's another one called just Space Invaders. It was very generically. A little plot spoiler here. The aliens killed people not by injecting them with poison, but by their fingers had ethanol coming out of them. And that's how they killed the town drunk, because he was already drunk. And the ethanol coming out of their fingers, of course, killed the drunk because he had alcohol poisoning then. It was formative, Dave.
Stuff.
I mean, like, all of my bad jokes come from a place, and it's those movies. So
got it.
Yeah.
Okay. So where does this? So,
anyways, PlanNine from Outer Space, very bad movie. That's also what this operating system was named after. It was never released.
So we're talking Dennis Ritchie.
I know.
Here.
Yeah.
I mean, holy crap.
Yeah. And so they just put it on the internet. I don't think it's going to go anywhere, but it's really interesting that they just basically released it. I think it's a distributed operating system as well. It's not like.
Have they upgraded it, or has they been working on it, or is it like the original stuff from the 70s or whatever, or 80s?
I think it's probably like a virtual machine that's like living online.
Right.
So
okay. Yeah.
The code, or actually, sorry, it's just the code that's online. Maybe there's a way to use it. You can download it. I don't know. I'm just looking at this, but I will say that their little logo bunny is adorable. So that's fun.
Yeah, it's pretty cute, little fat bunny. Yeah.
Anyways, so another operating system, and like so late too. You know, it's just really interesting that it's like this kind of like, I think it's going to be like a pet project for a long time.
They're just doing it for shits and giggles. I don't think they
Yeah.
seriously expect anyone to take it up. They're just,
Yep.
Yeah.
But pretty fun. So you can put that on your
good stuff.
Put that on your device if you really want to. You know, tell Blackmagic they can go and go and turn on a dime and put this on their device now with no hardware support.
Better yet, put it on your resume.
Yeah,
PlanNine.
Right.
From Bell Labs. Oh yeah, I'm fluent in PlanNine.
Oh! Sorry, I missed this. You can get a bootable PlanNine on Raspberry Pi. There you go.
Oh, there you go.
Yeah.
There you go. That's
to try that one out.
Yep.
Okay.
Yep. Although no, that's out of date, isn't? No, Raspberry Pi's out now. It has to be RISC-V, right?
Maybe. Yeah.
Yep. Well done. All right, we've got 5 minutes left. No, we got 10 minutes left.
10 minutes left.
What do we got? Geez, we're racing through stuff today.
We are. This was kind of interesting. There was someone over on Hacker News had posted about their self-study plan. I guess we talked a bunch about student stuff today, but I thought this was interesting. So he's trying to get into like brain-computer interface and stuff like that, and wants to get into hardware side of things. And so has been posting about like, want us to have some projects, but then also like just a list of the books that they plan to like work through. And I kind of balked at it a little bit just because it's like so book heavy, and the projects are like, oh, well, I'll figure out what projects they're here. And I think the main thing.
No, I was just going to say, like, it starts out, the first book is Intro to Electricity and Magnetism. Ugh.
Yeah. I mean, that's
gives me the heebie-jeebies, right?
Yeah. It's a university book. It's like a physics textbook, right?
Yep.
And I think it's just, it's a good, this is a great post. I'm glad this person posted it. I mean, honestly, it's so tough in this scenario of like, do you dive into the books like this, or do you have this other, and so, they list some early suggested projects and things like that. And so I thought you and I could kind of work through like a where to get started sort of thing, what are some early projects? And then like, I think honestly resources too. Like a lot of people like start with, oh, well, you should start with Art of Electronics. No, do not do that.
No.
So I don't know. I just feel like, this is an interesting kind of framing for getting started in electronics. I'm sure you've made videos about a lot of this stuff anyways, but
well, I've done a book. I've done a textbook shootout of the different textbooks available, excluding Art of Electronics, because it's kind of like a special case. It's kind of like a a go-to reference text rather than a learning book, so to speak. It's just its own unique beast. It's like, but I did actually review like 3 or 4 or near identical textbooks. A lot of them are near identical. If you look at the arrangement of their chapters and everything, they cover like they're almost, they practically copy each other, but they, of course, actually present the information in different ways. And some people will hate one way and they'll love another, and vice versa. So it's,
Yeah, I think, so given the person is looking to do like a brain-computer interface eventually, I would think, I'd first go out, if it was me telling this person what to do, I'd say, like, first go out, find out what that looks like. What is what's a standard kit you can buy? Maybe even go buy a kit to get started with it, just so you have that in mind.
That's what I would say. Because there's, I was doing this. I was doing like ECG type interfaces back in the late 80s, early 90s. It's not, these sorts of, things, you stick some electrodes on your brain.
Yeah,
and
right.
And you get some signals out, right? And you just hack around with it.
Yeah, and I think that gives a couple things. One, it gives you the confidence to build, right? 2, maybe it has a soldering component or some kind of assembly component, troubleshooting component. Like you always say, I hope your project doesn't work, that kind of thing. Like that's great. Like you need that struggle up front. And then, the actually having a reference point.
This is applications based. This is not learning electronics as such, is it?
I think it is, though. I think
it is. It's learning electronics in pursuit of, but it's learning electronics in pursuit of one particular goal, right?
Sure, but I think you need. I always say, I always think you need to start at some. You need to start somewhere, and I do not think it's a textbook. I do not think the first line you read is V equals IR. Let's talk about math. Like that's always my thing. And that's how every book starts because they have to start there.
I would agree, Mr. Contextual Electronics.
Yeah. And so I think starting from a kit though is great. And so if people didn't have this, and if they just needed like a default option, I'd probably point them at Ben Eater's course. Like, I think that is great too, because you get the computing, you get the electronics, you have the community. Like, I think Ben's stuff is just great as a centering force around like, and especially because a lot of people are coming in from the software side.
See, for those who don't know, he builds breadboard computers.
Right. That's right. And he has a kit now too. Yeah.
Oh, okay, cool. Right.
Yeah. So he has a YouTube channel that's great, but then he also has a kit, and there's a community around the kit as well.
Nice.
So I just think that that's great. And then still having that kind of like what you want to build in mind is really important. And then, building out a board, maybe understanding that sort of thing. I think a lot of the Hacker News kind of respondees also they have some very valid points that you need a theoretical basis. And I agree with that, but I just feel like if you slam a textbook at someone's face, they fall down. It's just I don't know.
Of course. Yeah. Some people will get rid. There are a select few that will excite them.
Yeah, exactly. And some people they start learning like that. And I think that's great. Yeah.
Yeah. No, the vast majority will not like that approach. They'll just.
I think a lot of people listening to this, it's going to resonate more of like, let's go find a thing. But I think that leaping forward, this is how I think. We talked about college curriculum too. Like, I wish there was I think my favorite college courses that I've heard about have that end goal in mind. They have that like build out a thing in mind. Larry Sears, who has been on the show, he's taught at my alma mater. Like, he worked out of the art of electronics, but he had things that you were trying to build. And then you struggled all the way along, and you needed a lot of theoretical knowledge, but having that end goal in mind is really important, I think.
Yep. I totally agree.
Yeah.
So I think this is an excellent approach. Have you have an idea in mind of something you want to do or something you want to create, and then learn the necessary tools to do that.
Right. I think the important thing to know is that like electronics is just a slog sometimes, and like if you don't have that like motivating end goal, I don't know.
Oh yeah.
It's just,
and it's vast.
Yeah, exactly.
The thing about electronics is vast. Right. I can guarantee you can be like the world's, most ancient graybeard, right? You've worked on everything. I guarantee there are a million different things you don't know and you've never worked on.
Yeah, that's the best part. That's why we're here,
there
man.
Is there is no end. I know. There's no end. Yep. There's no end to it.
Get a good grasp on one thing, and it's like, okay, I'm gonna go learn something else now.
Something else is new.
Time for RF
doesn't
land.
Matter.
Time for more firmware.
50 years you could be working in the field, and still you haven't, touched countless things. It's just crazy. So
yeah.
Yep. Anyway, that's I wish him luck.
Yeah,
hope that works.
Yeah, I hope so too. I think that's it's a noble goal regardless, and I think that having
and just writing it down helps.
Exactly, and gathering people to your having some people back you and just like, hey, how's your brain computer interface journey going? That's really that can really help. And sometimes it won't work out. That's fine, but yeah. So thanks to the author of this post.
All right, last dibs. Is there any last news? Is there any breaking news?
I printed a PCB vise.
You do know you can buy them, right?
I do, but I have a printer, and you know how 3D printers go. I like it.
Then you've got a hammer. Everything.
That's right. Exactly.
Yep.
I've actually been thinking about my Panavise. I've got like one of those huge Panavise ones, which they very nicely sent it to me.
Yep.
I don't think there's any other piece of equipment on my bench that gets in the way more than that thing.
I know. Yeah, I've got an even bigger one on a base plate with all these big flexible arms coming out of it.
I think that might be the one that I have as well. Yeah.
Right. Yeah. It just gets in the way. Yeah. I mean, I've used it a couple of times for various things, but otherwise, no, get that damn thing off the bench. It's like, no, I want some small little tiny special purpose holder jig.
Right. I have a really big board that I'm working on right now, so it has been good for that. But even still, I think that's tough. I think I like
I really like the magnetic PCB-ite things. Yeah.
Yeah, I was going to mention those too.
I call them PCB-ites. I know.
Right. I can't say PC
it's
byte.
It's supposed to be PC byte. No, I'm sorry. If you're going to capitalize PCB, no, do not capitalize PCB and then expect me to say PC byte.
I agree.
Put a hyphen in there or lowercase b.
Yeah.
Damn it. I'm going to die on that hill.
I really like those as well. I don't use the probes as much as I use the just the little holder thingies.
Oh, the probes are very handy. When you need them, you need them.
Totally. Yeah. When you need to 4 signals and you need to do that at a time.
Yeah. You just need to hold things in place. Oh, jeez, Era.
Yeah. I think that's whoever came up with that very, very clever idea. It definitely hit the right market.
Yep.
But now I also have I did a 3D printed jig for a board that I'm working on. So that was also a good use for my some people do that kind of naturally. They're in that mode. I'm trying to get better at it, having some jig building though. I'm getting jiggy with it, as it were.
Got it.
That was terrible.
I won't go down that path. Yep. Cool.
Anything else?
Intel are expanding their fab plants. It's another year. It's another fab plant expansion.
So this one, so this is a little, because I've talked about this a lot, I've always predicted that I think they'll split out the businesses eventually. I think this is the first step into that.
Right.
I think that eventually they'll be like, we have a foundry now, but also we're going to split out the chip business. So I just feel like that's on the way, It really is not, it's not going to impact anything.
That would not surprise me either.
And also, what's it called? TSMC is also apparently building a plant. These are both in Arizona, which if people have never been in Arizona, it is, I've always wondered this, why the desert? It's so hot there. It's so hot. But maybe something with moisture or availability of power or something like that. But maybe lack of weather.
You know that 9/10 of Australia's like that.
But they're not building fabs there. So what gives?
No, they're not.
I mean, I know some of it is existing fab capability. So there's talent in the area, that sort of thing. We've talked about in the show before. But Arizona in summer, I don't. Nope. Hard pass. I guess maybe the because everything's so temperature controlled anyways, that's not a big deal, and they're consuming so much power anyways. That's fine. They'll just park it next to a power plant and burn a bunch of coal or gas or whatever. But
there was an article that I retweeted. I don't know if I'll be able to find it quickly enough in time here. It was about China started their own fab. For this startup company that wanted to do their own fabs from scratch, and it just sits abandoned because they couldn't get I'm not sure if they couldn't get the people to run it or the money ran out, or it's a pretty sad state. And they
both are very possible, I'm guessing.
Yeah, and they put they already put I think billions into it, and they've got nothing to show for it after 5 years. It's just gone nowhere, and it's sorry, it's not easy to spin up a fab.
Yep. Oh yeah, it's a many year thing, and
talking about the sunk cost fallacy. It's like, oh, we've already spent 2 or 3 billion, but we're going to need another 5 billion. Should we just, take our $2 billion loss now, or should we, keep going?
Yeah, I mean, like, so much of it is the infrastructure piece, right? That's like really what a fab is like piping and water processing and power and all the guts of it. And then that's about half the cost. And then the other half is all the fancy ass machines you have to put in there. Really fancy ass machines. And then getting fancier. So,
Yep. But you can't just build it in some warehouse. No, it's got to be like Class X clean room. It's
I mean, the clean room is not as bad as it used to be. I mean, like, because they isolate now in the containers, but yeah, still clean room, and it has to be significantly large.
So you're saying there's sealed containers that can already cleaned that can come into a dirtier sort of environment, and then they go into the machines which are inherently clean inside, and then it never. Okay.
Yeah, so I think that makes it the fab that I used to work in, which you mentioned, is also they're expanding Samsung as well, maybe, which also shut down. Oh, that's one thing we didn't bring up when the Texas thing happened a couple weeks ago, when all the power went out.
Oh yeah, one of them shut down. There was an article
everything
about
shut down. Samsung shut down.
How to try and spin up a fab after
NXP shut down. The first thing that happens when I've mentioned this on the show before. The first thing that happens when you got an etch chamber and you got a whole bunch of plasma floating above a wafer, and then you shut the power off. Yeah, all that stuff that's floating drops a whole bunch of crap, and you scrap a lot of wafers.
So you have to run those. 24/7, do you? They do they have to keep power to the whole thing?
No. So it's like you put a wafer in, and then you pump in a bunch of gas, and then you turn on the RF generators, and then that strikes a plasma. But then imagine what's a good way to think about it? It's kind of like an acidic cloud. That's kind of like the way to think about it. And so it's kind of like eating silicon or polysilicon or solder or resist material. And then it's kind of like floating up and around there. And then it's, it's still moving through, and then it's getting sucked down into the turbo pump below it. Right. And so it's all getting moved around, but there is just stuff floating right in the plasma up above.
Yeah.
And so then you turn the power off, and then that acid cloud just is like plop. And so, but when you're working with such fine detailed things, you've pretty much anything that's in process, unless you can possibly clean it off immediately, it's scrap.
Oh yeah,
and so
it's gone.
And then you can hopefully seal up the container.
But I thought there wasn't much loss in just losing a couple of wafers, like a couple of 300 mil wafers. I didn't think there was a. I thought the cost is added in every extra process. Well, I guess if you were right at the end of all your process steps, that's added all the value to it. Then if it happened early on in the process, then actually scrapping a
that would definitely
wafer is not.
I mean that would definitely suck. I think there's that, and then I think but then you think about some of the stuff is also, so you have the ones that are in the chamber; those are probably toast.
Right.
You think about the ones that are in the machine, as long as nothing got out of the machine.
How many would be in there at once? How many?
So if you had the newer machines are a lot bigger and more expensive than even the ones I used to work on.
Yeah.
Which was now 15 years ago.
Right.
And so, but the ones I worked on had 3 chambers of, so 3 pods or FOUPs that were 25 wafers each. And then at any time in the machine, you might have 5 chambers, and then everything else is kind of sitting in the FOUP waiting to get processed through.
So we're talking hundreds of wafers here.
Oh yeah. I mean, at least. I mean, it depends how big the fab is too, right? So.
Yeah, of course, it could be thousands. It could be thousands. So if that power fails, wow.
So there's ones in the chamber, and then there's also the ones that are in waiting, right? So you think about, I used to work in etch, so everything's already got photoresist on it. And if you leave the photoresist on too long, you have to basically take it all back out and wash it off, because it's corrosive, as it can be corrosive.
Right. Oh, of course.
And basically, when a fab shuts down for a couple weeks, anything that's in process, I would assume that a lot of it just gets tossed. I don't know how that would work. I never had to deal with any of that stuff, and a lot of this stuff is working on an old memory. But that was probably not cheap. And given that we're in a chip shortage too, I'm sure those chips are already spoken for. So now you're
we're already in a market where there's component shortages. So it's even impacting my own product.
Oh, everyone, it's just, finally it hit you, huh, Dave?
Oh, yeah. Finally. Yep. They can't make enough multimeters. Oh, we can give you 60. That's all we can give you. You know, this month. You're gonna have to wait another month or two. You know, before we can even make more than that.
That's nothing, man.
Geez.
Yeah.
You know,
I just keep seeing like car factory shuts down. I saw someone post the other day like.
Yep, somebody retweeted it, and they laid off their workers because they had component shortages.
Yep.
So they lay off teams of people.
Right, and then you think about all the add-on stuff as well. I think it was Sam Snyder, maybe. I don't remember who it was, but like just the add-on effects of it all as well. Just thinking about how supply chain kind of like goes down the line. So
it's crazy, and then suppliers shut down because they're not getting orders from the auto factory, and that was their 90% of their business.
Yep, totally.
And
sucks.
Sheesh.
Sucks.
Bloody manufacturing.
Yeah.
Wouldn't want to be in it for quids.
Yeah, whatever that means. What does that mean?
Sorry, that's an Australian expression. A quid. Quids, money.
Quids. Oh, like the British people say.
Quids.
Like
it's like old currency.
Right.
Yeah, quid. Yep. So you have actually heard of it. There you go.
I know what quid is, but you said I would never want to be in with the quids. So like that sounds like a
4 quids. Wouldn't want to do it for quids. It doesn't matter how much they pay me. I'm not going to work in that industry.
Aussieisms.
Yep.
We got other links on the subreddit. People can check them out. We still have the survey open. If you have not done that, do that. It's closing soon.
Yep.
Do it.
Yes, please. I'm reading the comments.
All right. Talk to you soon.
Catch you next time.
When you strike it big selling your latest whiz-bang schematic as a non-fungible token, be sure to remember us little people who suggested that stupid-ass idea here on The Amp-Hour. You can share some coin and join the crowd at patreon.com/TheAmp-Hour. For all you normal people, you could try that as well and join our Discord. Come discuss NFT schematics and other terrible ideas with us.